Hi guys, we are starting our last unit, and this last unit will be on basic probability and statistics. And this is the last topic we will have before our TN ready, and with you being out for English, it is going to be very important to make sure you watch the videos fully. Along with each video, you will have homework for the first 3 videos and classwork for the first 3 videos. After that, you will have just homework assignments. So it's important to stay on top of it, know what's going on, because this material is on your 10 ready. So some basic probability definitions. First, what's a probability experiment? It is an action or trial to obtain a sample space. So maybe we want to flip a coin. The act of flipping that coin would be the action or trial to obtain the sample space. Outcome is the result of a single trial. So when we flip that coin, we would record our outcome, which would either be heads or tails. But it's the result of that experiment. Sample space is the set of all possible outcomes, and of course if we are flipping a coin, that would be heads or tails. An event is a subset of a sample space, and we'll talk more about that in a few moments. As a reminder, and you've already seen some of this, a probability can be written as a fraction, a decimal, or a percent. Make sure you're just following the instructions and following the instructions on your rounding as well. So just take a look at your instructions, and typically it will tell you what to do there. So for the following, we want to write a sample space for each of these. And remember, a sample space is the set of all possible outcomes. So when you roll a 6-sided die, the outcomes are the faces of the die, which would be 1, 2, 3, 4, 5, and 6. Notice I did use set notation there because it is just a list. So next we're looking at flipping a fair coin. And of course, we've actually already mentioned this. Our sample space would be heads and tails. The next says flipping a fair coin twice, and so there's a couple ways that you can approach this. One way you can make a tree diagram, so that's what I've done over here on the side. So your first flip could land on heads, it could land on tails. The second flip is independent of the first, meaning the second result is not influenced by the first. So you could then have a heads or a tails, or heads or tails. So our sample space would be heads and heads, heads and tails, tails and heads, tails and tails. There are 4 events in that sample space. A simple event has only one outcome, and so you're given 2 situations here. You're doing an experiment where you have a fair die, and you have a coin. And so you're looking for tossing heads or rolling a 3 versus tossing hands and rolling an even number. Which event would only have one possible outcome, and that would be the first. There's only one way you can toss heads and roll a 3. Whereas tossing hands and rolling an even number, you could have heads and 2, heads and 4, heads and 6, and there are 3 possible outcomes there. So we're going to start off finding some probabilities by using a deck of playing cards. And so if you're not familiar with what's in a deck of playing cards, I will post on Canvas on the calendar a sheet that helps you take a look at that. But we will also talk about those right now. So in your basic standard deck of playing cards, there are 52 cards in the deck. That is not counting a joker. We are not working with jokers, just a basic deck. There are 4 suits: spade, diamonds, clubs, and hearts. There are 2 colors of cards, red and black. There are 12 face cards. So you have a queen, you have kings and jacks, and you have 4 suits. And so all suits have a queen, a king, and a jack. And then how many of each card do you have? There are 4 cards. There are 4 nines, there are 4 queens, there are 4 jacks, there are 4 kings, and so on. So let's take a look at some probabilities here, and you'll see me write some of these in different ways. So you're asked, what's the probability of selecting a random card and getting a 9? Well, there are 4 nines out of 52 cards, and so the probability is 4 over 52. You can certainly reduce that fraction and tell me it's 1 over 13. You can write it as a decimal. I just typed this in my calculator. Or you can write it as a percent. Any of these would be acceptable. What's the probability of selecting a jack from a deck of cards? Once again, there are 4 jacks out of your 52 decks of cards, and so that would be the same as above. What about a red queen? There are 4 queens, and 2 of them are red. So there are only 2 red queens out of your 52. Once again, you can simplify that as 1 over 26. You can type it in your calculator. There are different ways to represent that. So we'll go to the next page. So first, it says, what's the probability that you randomly select a card that's a diamond, a heart, or a club? Well, there are 13 diamonds out of your 52 cards. There are 13 hearts out of your 52 cards. There are 13 clubs out of your 52 cards, and so there are 39 cards in all out of your 52 that would be a heart, diamond, or club. Another way to actually look at this is we're really finding the probability of not being a spade. And so that would also be 39 out of 52. There are 39 cards that are not spades. So the next situation says heart given red. So what does that mean? That means you know the card is a red card. You already know that. So that actually will change your denominator here because there are only 26 red cards. Of those 26 red cards, how many of them will be hearts? Well, you have to know a little bit about cards in order to know this. So actually, all of your hearts are red. Again, you can go look at your sheet if you need to know some more about cards. So therefore, there are 13 hearts that are red. So now we're going to a sock door. We have 6 red socks, 8 yellow, 4 blue, 10 black. What's the probability? We are randomly selecting a sock and we pull out a black sock. Well, there are 28 socks in all. If you haven't figured that out already, when you add these together, you get 28. Of those 28, 10 are black. And yes, you can type that in your calculator and you can get the decimal. You could also write that as a percent. Either one. What's the probability that we draw out a black sock or a blue sock? So how many socks do we have to pick from? We have 10 black, we have 4 blue. And so therefore, the probability is 14 over 28, which is actually 1/2. So what's the probability of a blue sock? Well, we only have 4 blue socks out of the 28, which reduces to 1/7. What's the probability of a red sock or a yellow sock? So we have to figure out how many red and yellow socks we have. We have 6 red, 8 yellow out of the 28, which gives us 14 over 28, or 1/2. So that's some information about basic probability. Next, we're going to look at some vocab words. And so let's talk about the law of large numbers. So the law of large numbers tells us that when we repeat an experiment over and over and over again, the experimental probability will approach what is called the theoretical probability. So you could tell me that if we toss a coin, what's the theoretical probability of it landing on tails? Well, that would be 1/2 or 50%. But if you were actually to perform an experiment and you were to toss this coin 10 times, would it mean that exactly 5 would land on tails? Well, probably not. I mean, try it. Take a coin, toss it 10 times, see what happens. You may get 3 times it lands on tails. You may get 7 times it lands on tails. So the thing is, 10 isn't big enough. It's not a large number. Well, what would happen if you were to toss this coin 100 times? You're probably not, if it's a fair coin, going to get 70 tails. You would probably get something close to 50. So as you repeat the experiment over and over and over again, the experimental probability will approach the theoretical probability. Probability is always between 0 and 1 inclusive. Of course, if the probability is 0, that means it's never going to occur. If it's 1, it means it will always occur. And we can also talk about what a complement is. And so we'll denote it and we'll talk about this in just a moment. So let me write this. The probability of E complement is 1 minus the probability of E occurring. We can also write E complement instead of with a line over it. We can write it as P, probability of the event prime, and that's what that symbol means. It looks like a apostrophe. We actually did that up above in problem number 4. So in problem number 4, I said that we could actually have looked at problem number 4 as being the probability of not being a spade. And so the probability of it not being a spade, the complement of that would be it being a spade. So we can actually find the probability of not being a spade by doing 1 minus the probability of it being a spade. That's its complement. So therefore I could do 1 minus 13 over 52. And so that would end up giving me 39 over 52. Not being a spade and being a spade are complements of each other. And the reason why that works, the probability of an event and its complement will always equal 1. Think about it. The probability of not being a spade plus the probability of being a spade has to equal 1. That covers every single one of the cards we have. And so from here we just did a little arithmetic. We solved for E. Then we solve for its complement. So that's called the rule of complements. We'll work more with this later, but it is pretty intuitive. So let's go back to our sock example. 6 red socks, 8 yellow, 4 blue, 10 black. And then we're also going to talk about cards as well. So we want to know first, what's the probability of not drawing a red sock? We could approach that a couple of different ways. We could do 1 minus the probability we do draw a red sock, which would be 1 minus 6 over 28. In other words, 22 over 28. Now you could certainly approach that as counting up the socks that are not red and seeing that it's 22 over 28. So what about the probability of not drawing a yellow or a blue? I'm going to work this one a little bit differently. If we don't draw yellow, nor do we draw a blue, what kind of sock are we drawing? A red or a black? Well, how many red socks do we have? How many black socks do we have? We end up with 16 over 28. So next we want to look at what's the probability of not drawing a face card. And yes, we could look at that as what's the probability of drawing a face card. And so if you remember from earlier, we end up with having 12 face cards. Okay? So if we want to look at it just as the problem itself and not take complement, there are 12 face cards, so that means 40 out of your 52 cards are not face cards. Now the other way we can work this problem is we could do 1 minus the probability of finding a face card, which would be 1 minus 12 over 52, which would give us 40 over 52 like we already said. Again, there are different ways that we can work this problem. Number 4, the probability of not drawing a number card. So let's do this as the probability 1 minus the probability of drawing a number card. So it will be 1 minus. How many number cards do we have? Okay, so how many number cards do we have? So your number cards are 2 through 10, and you have those for each suit. So there are actually 36 number cards. 9 in each suit, so 9 times 4 is 36. So here it's 1 minus 36 over 52, which would be 16 over 52. So now we're actually looking at doing some things in a sequence. So what would be the probability of drawing out a red sock, a yellow sock, and drawing an ace? Well, how many red socks are there? There are 6 out of 28 red socks. What would be the probability of drawing a yellow sock out? Well, there are 8 out of 28 yellow socks. And how many aces are there? 4 out of 52. So you type that in your calculator, you're going to end up 0.0047. Next, what's the probability of not drawing a queen and not picking a red sock? So how many cards are not queens? Well, how many cards are queen? There's 4. So 48 cards are not queens. And we will multiply this by the probability of not picking a red sock. There are 6 red socks, so there are 22 socks that are not red. We end up with 0.7253. Okay, so we're looking at our last page here, our last section, and we're looking at tossing a coin and spinning a spinner with equal space 1, 2, 3, and 4. So it asks how many things are in the sample space. Well, one way you can look at it is how many outcomes are there for a fair coin? There are 2. How many outcomes are there for our spinner? There are 4. So therefore there will be 8 events in our sample space. We could get heads with 1, heads with 2, heads with 3, heads with 4. Tails with 1, tails with 2, tails with 3, and tails with 4. So the first one says find the probability of tossing and getting a head and spinning a number greater than 2. So we're looking for head and greater than 2. So head greater than 2. What options would that be? We only have 2. Heads and 3, heads and 4. So therefore it's 2 over 8 or 1/4. Find the probability of a tail and getting an odd number. So what are our options there? Well, what are our odd numbers? We only have tails in 1 and tails in 3. So once again, it's 2 over 8 or 1/4. Find the probability of tossing tails and spinning a 2. Well, there's only one way that can happen out of our 8. So that would be 1/8. What would be the complement of tails and an even number? So what would be the probability of tails and even number? What would be the complement of that? It would be 1 minus the probability of tails and even number. So that would be 1 minus 2/8, which is 6/8 or 0.75. So that's our first set of notes. Hopefully you can see that it's pretty straightforward. Follow up with the classwork and the homework. I will also provide you the answers with that so you know if you're getting these correct or not. And I will see you in the second video.